In our previous video, we saw how white transformation works. We also saw the practical demonstration for group by and how do it shuffle. We also try understanding the concept of white transformation by making two data frames and joining them together and show how shuffle and filter work in parallel. In continuation to that, next video. Hello to world, welcome back to another video. So today in this video, we are going to discuss about repartitioning and coalesce in Apache Spark. But don't worry if these terms are confusing right now to you. By the end of this video, you will be exactly knowing which one to use and when to use when, okay? And what's the major difference between them? That is the important thing. So let's take a simple example. As you have seen, I have taken a data frame here, okay? And if before jumping into anything, you should know that default size for any partition is around 128 MB, okay? And not around, it is exactly 128 MB, okay? And if I consider this my data frame to be a 200 MB, okay, and I made a partition out of it, okay. So repartitioning is all about you have make the partition, then you are again doing a repartitioning of that, right? So if I take one partition, let me draw one partition over here, and this is my one partition, okay. And let's say this is of around how much? It is about 128 MB, okay, 128 MB default size. So how much the below one will be left? That is the one which is present over here. This one, the record 15.6. This will be around 128, 200, around 72 MB, correct? 72 MB, 72 MB, correct? 72 MB. So this is my basically a repartitioning I have done, and this is my how my partition has been divided. Now what I want to do is I want to, I'm not okay with this. I want to repartition it because I want to create more partition out of it. So how can I achieve it? Okay, so for that, what I will do, let's say this, if this is my data frame, so I will say data frame dot repartition, P-A-R-T-I-T-I-O-N, repartition, and currently it is having two partition. I want it of 10. So now what it will do, it is going to create 10 partition of this entire data frame for me. What is my entire data frame? This is my entire data frame, correct? So it is going to create the 10 partitions for me, okay? So this is the beauty of this repartitioning. And why we use repartitioning is because sometimes we saw memory issue, and at that time we saw, okay, it is spilling over the disk and we want to keep into the memory. Let's do a repartition of it. It will also help us to put that same kind of data. And if there might be the reason, like some partition are empty, some partition are not empty, some partition are completely full, some are shallow full. So at that time we will shuffle it and we will do a repartitioning of it. But majority of the time, repartitioning is very complex because complex operation in the sense it requires shuffling of data is required, okay? So every time I have already informed you, like whenever you are going to shuffle anything, right, you have to be very cautious about it. But this is not the very true case every time, right? Let's say you have 10 partition, okay, of this data frame itself. Let me do one thing for you guys, and if I can do it, I'm not able to select it actually. So let's suppose we have 10 different partition out of it, okay? Let me remove this. And Control Z. Let me remove this. Let's say from this data frame, I have 10 different partitions. Cool. 10 different partitions, and 10 partitions are there, and only let's suppose 3 partitions are filled. 3 partitions. Okay, rest 7 are empty. In that case, you need to do something, right? So whenever you want to reduce the partition, right? So you will do df.coalesce. That is coalesce. This coalesce is different from the one which we use in basically our SQL. Okay. So we will do coalesce of this, and this doesn't require any shuffling until and unless your data is in different executor itself. Okay. Executor is a different physical machine, correct? Now, by the time we have known that, right? Executor is a completely different machine. If their data is in different executor machine, then you have to definitely do the shuffle, but not here. When your whole data is in single executor and multiple partition are there inside a single executor, okay, that time df.coalesce will have. So that was enough of the theory. Let's jump into our practical concept now. So I will use our we were into this notebook, learning notebook, and we have created Databricks second. come and head over it. We have already discussed about partitioning. We will skip all it, and let's create a new cell and start with our markdown MD, and we will name it as repartitioning and coalesce. Okay, so make your heading correctly. Okay, so it will be a reference for you. Repartition and coalesce, COLEASE. Okay, we have to
Shift.
control enter, and if you want, basically you can also give the heading to it. Okay, just like this. We have to you have to bring it down actually. Okay, and then select all over here and do a heading of 1. Control enter. So this is your heading. Okay, first of all, I want to get a data frame. Okay, so let's take the same data frame which we have from above, and this was our data frame, right? Initially I have used one data frame for writing as well. Okay, I believe I have lost that data frame. Let me copy the libraries by the time. So I was having a data frame actually. Let me copy it from my GitHub. Where is my GitHub? Okay, here it is. And also get it from my GitHub. No issue on that. I've already discussed about the libraries over here. So this is my data and this is my schema for that data. Okay, and I am creating a data frame out of it. If you are not getting what code I have written here, that's completely normal. The concept which we are learning here about is repartitioning in college. We are not learning which we are learning here is about repartitioning in college, and we are not learning about how Pyspark is working. That will be a completely different video if you want. Okay, so let me run this first. Okay, let me run this first, and we will wait for the cluster to get up. And since it is a serverless, so it will be running very quick for us. Okay, and let it run. I want to write some other code for it. Okay, since it is going to give us a data frame back, right? So what I will do is df.select SCLECT select, and I will use Spark API to get something. And what I want to get is Spark partition, SPARK underscore PARTITIN partition ID. Okay, I want to get Spark partition ID, and that is also the distinct one, DISTINCT distinct. Okay, and I want to get the count for it. Okay, I want to get the count for it. Definitely this code which I am writing over here, you don't have to memorize it. Okay, so our data frame has been created. Let me rerun this, and I want to show you something. Okay, just wait for the output for this. So it is running and it is showing as 1. So basically there is one partition currently for us. Okay, now I want to make an explanation of it. Okay, I want to do a repartitioning. Let's do the repartitioning part, then we will do the explanation of it. df equal to df is equal to df dot repartition. I want to partition this into 3 partition. Currently, just see this. It is 1. Correct? This is 1. This is 1 right here. As soon as I am executing it, it has executed. It has given you nothing. Let me re-execute this previous cell, the 17th cell again. It will show you output as 3. It has created 3 different partitions for you now. Okay, it has created 3 different partitions. See the output. The output is very clear. Now let me go and give you a very clear explanation of it. df.explain. Okay, and it has done shuffle inside. How can I say that? When I will do df.shuffle, right? df.explain, right? Now let's read the physical plan from the bottom. It has local table scan, then Photon come into the picture. Photon is a executor, like accelerator for query. Okay, we will discuss. You can skip this right now. Just understand this. This is an accelerator kind of a thing. Okay, then it has done a shuffle exchange. Then it has done Photon shuffle, merge state, repartition by basically their ID. Okay, and at the end it has converted the column to rows, and then Photon result stage. That's it. So partitioning has been done. Repartition was done, and earlier we were having 3. Now we were having 1. Now we are having 3. Okay, so that is the major thing about this. You can do the repartitioning in this way. Now I don't want these much partition, as I know my data frame is very small, right? If you see this, my data frame is very small. 1 partition is enough for that. How can I coalesce it into it? So df is equal to df dot coalesce, coalesce function, and I want to make it back to 1. Okay, and let me run it. Okay, it has ran. And now what I will do the df dot explain again. Okay, I will do df dot explain again. Now it will show me the physical plan again. Now again, coming back to it, local you have to read it from the below. Okay, we have to table scan, then photon row to columnar, then photon sort, and it has done the again round robin partitioning. 3 repartition has been applied to it, and then shuffling photon stage result came column to row, and then it has made a single one partition to it. The reference node has created one partition for us. Okay, that is how it works. Now if you check again how many partitions are there after the coalesce, you will see this output has changed to 3 to 1 back. So this is how our repartitioning and coalesce work into the real world project Apache Spark. And definitely we will be learning this. These are concept right now. Okay, these are concept, and concept has to be written in your mind, because when we will be creating the projects, right, I'm not going to explain you what it is doing, why it is doing, why we are doing this. You should be intelligent enough to understand why we have done this. So that's for all this video, and hopefully you have liked the video. If you have liked the video, do like, share and comment, and do comment actually. That will help me to know where I am lagging and how more interactive I have to make this video for you guys, so that we both can grow each other. Okay, thank you for that.